everybody. So a student sent me a question about this particular question on my math lab. And their question was, how do you look at this frequency histogram? That's what I would call that. And determine the class width. Okay? Alright, so they had answered 35.7. I can kind of see that based on the numbers and maybe trying to figure out what lies between these points in there. But the class width is 10. Okay? So let me tell you the short answer to that. If you take any one of these midpoints, because these bars are graphed based on the midpoint. So we could say this bar right here lies at 55.4, okay? Or 54.5, sorry. And then this one is 64.5. But if you subtract any two of those, that's how wide the individual bars are. Okay, so that's what we mean by the class width. Okay, so if you took 44.5 minus 34.5, that would be how wide any of these bars are, and that's 10. But if you took 64.5 minus 54.5, that would be how wide any of the bars are, and you still get 10. So it's like, you know, no matter how you do it, no matter which two of these adjacent midpoints you subtract, you get 10. That's the class width. That's how wide the bars are on the graph. Okay, so that's the short answer to how you'd answer that one. But I think it's because I can make this video for the general larger topic, and I might also run through it like this. So that question sort of can be seen to have its origin sort of like this. So here's another thing I took from my math lab, where we're given the raw data. It's not organized in any way. It's just a bunch of numbers. It's like they took some data, I don't know, cash register receipts, who knows. But all these numbers are supposed to represent the amount of dollars spent on books for the semester, maybe by individual students. It's unorganized. I look at it, I can't really draw too many conclusions because it's all mixed up. Okay, all right. Now, if I'm going to take this to the point that we're seeing it like that, then I might go about this way. First, that's raw data. It's hard to look at raw data. So you can, on my math lab, you can download data and look at it in Excel and organize it that way, make it a little bit easier to see, or you can open it in StatCrunch. And I made another video about StatCrunch. But let's say that when I did this problem, I downloaded it in Excel, and there's all those numbers that you see there in the original question. All right, you see all these numbers? There they are. And then I sorted them. Okay, I typed in sort and dragged through this column, and then it arranged them from least to greatest. It's going to be easier for me to look at it that way. Okay, all right. So let's do this. Let's find some things about this data set, and I want to take it full circle to tell you a little bit more about what's happening here and where this came from. Okay, because you may have to make one of those from scratch in some of these questions, and I can explain why we find the class width by just subtracting any two of these midpoints. Okay, any two adjacent midpoints. So anyway, what I need to know are three things: the sample size, meaning how many numbers are in here. Okay, the range, which is the max value minus the min value, and the class width. Oh, so that was that thing that this question was asking me about in the beginning. The student sent to me, what's the class width? I was looking at that trying to figure it out. I told you how to find it right away, but that's one of the things we'll find. So sample size, well, if I guess I could count these numbers, but since I downloaded it in Excel, I can see there's, let's see, there's 29 numbers. Okay, so good. I've got that number. That's going to be 29. Okay. 29 for the sample size. Next thing, what's the range? Meaning, what's the maximum value minus the minimum value? So maximum value, if I look at it, since I was able to sort these least to greatest in my math lab, is 513 and then take away 50. Okay, so let's see, we're going to get 513 for the maximum value minus 50, and that's 463. Okay, so like from the smallest number in the data set to the biggest number, the range, the span is 463. Now the class width, which is ultimately, if I take this raw data and I want to make a graph like this, a frequency histogram, because people like graphs, people think graphs are easier to look at than numbers and data, then that's entirely based on knowing what this class width is. But you just take the range, which we found already, and you divide by the number of classes, okay? So we'll get 463, and the number of classes is always up for discussion in general, in principle, but at least on my assignment that I made for you, it will always tell you. See how it says construct a frequency distribution for the given data using 6 classes. So I'm going to use 6 classes. Okay, now if I divide that, I get 77 point something. Let's see, 463 divided by 6, 77.17. But we always round up, okay? For the sake of making these frequency distributions and frequency histograms, that's the way that we do it. Okay, always round up. So this is going to be 78. So the class width is 78. So that would tell you that, well, if I was making this type of bar graph with this data that I was given about how much students spend in the bookstore, then those bars on that graph would have a width of 78. Okay? All right, now I'll show you what we do with that width next. Okay? I want to put together something like this. I want to divide all these numbers that I'm seeing into groups of equal size. Okay? Now, the way that we arrange that is like this. I start with the lowest number in the data set. That was 50. Remember, I sorted the data. 50 was the smallest number. Okay? All right. And then I go through like this. I will add the class width to get the next starting number. Okay, so let's say plus 78 and plus 78 and so on. So I do that all the way through as I break this down into classes. Now, if 50 plus 78 is 128, that means this first class goes right up to 128, which is 127. Okay? And if this next class, through adding 78, goes to 206, that means this one has to go right up to that 205. So that's how, if I just keep doing that all the way down until I get 6 classes, there ends the last one, well, then I've broken down the data into groups. So that first group will be the students who spent between $50 and $127 at the bookstore, given that that was the original description of the data. Okay, that's what these numbers meant. And then that second group will be the students that spent between $128 and $205 at the bookstore. Now from here, I tally the frequency. Okay, I count in this data set how many students spent between $50 and $128 at the bookstore, $127 at the bookstore. So that would be these, and that's 6 students. So when I put frequency here is 6, that's just how many of them did that, all right? And then I go through the same way with the other classes, the other groups. Now, the midpoint was what that original table was based on that I started the video with. So those just have midpoints. So instead of like trying to fit the classes on there, we could just put one number in the middle, okay? And that will tell you like, well, it's about right here, but then there's a width around it. And then the next bar is over here and so on. How we find the midpoint is like this. Let's do it this way. The first midpoint, what we want to do is average these numbers. So I take 50 plus 127 and I divide by 2. Okay? Alright, so 50 plus 127 divide by 2, 88.5. So there's my first midpoint. But every other midpoint is also spaced by the class width. Now remember, I found by standard formula that the class width should be 78. So once I find the first midpoint to be 88.5, then I can add the class width to get the next one and the next one and so on. Now, I said I was going to bring this full circle. That's why when you're looking at a finished frequency histogram, if it's based on the midpoints, subtracting any two adjacent midpoints will tell you the class width, because that's how it's made in the first place. It's just like working backwards. All right. Okay, now there are other numbers here. There's the relative frequency. The frequency says, like 6 right here, says there were 6 students who spent between $50 and $127 at the bookstore. That's what that 6 means. The midpoint is the middle of this group, okay? The relative frequency says 6 out of 29 total, okay? Because how many students total were in this data set? If we go back to that original data set, it had 29 numbers in it, okay? So the relative frequency is out of. So 6 out of 29. If 4 students spent between $128 and $205 at the bookstore, then that makes 4 out of 29, and so on. And you might convert those to decimals depending on the instructions for MyMathLab. One more thing, the cumulative frequency is the so far frequency. Think of it like this. As I were to go through all of these numbers, up to 127, there's 6 students who spent that much. Up to $205, there's 10 students who spent that much. Up to that amount. So, well, how to get that? Well, if 6 students are in this spending group and 4 in that spending group, then that means 10 so far have spent up to $205. Okay? So to get the cumulative frequency, we just add, you know, the new result, the new frequency, to the old cumulative frequency until we're done. Okay? And it will end in 29 because 29 is the total number of students in the data set. So anyway, that's how you make a frequency distribution. I can take these numbers, and if you want to visualize it, people like to visualize things, I can draw a bar graph like this, okay? Frequency here, I counted up to 9. I accommodated every single one of these numbers, okay? The midpoints are on there because it's easier to fit the midpoints than it is each beginning and end of the class and so on. But what you're looking at right here is the finished product of making this frequency distribution, okay? So in case you would need to make one of those from scratch, that's where this comes from. That's the process to take the raw data and build something like this as a finished product. We might prefer that because, like I said, people like pictures more than they like numbers. It's a little bit easier to see and draw conclusions from something like this than a bunch of numbers, even if I've neatly organized those numbers into a table.